picking up on like keywords or key phrases, because that is going to help you a lot for chapter 5. But like I said, chapter 5 where students struggle the most, because this is where you kind of have to read the question carefully to be able to decide what to do. So right now what I'm going to go ahead and do, I'm going to go ahead and share today's quiz. Just know for the quiz, the number are going to be different, but the concept are the same. Just because everybody should have had different number. So just know the numbers will be different, but pretty much the concept should be the same. All right. So we'll go over question 1 all the way through question 6. So let's do this. Annotate. Go. And if you do have questions, just stop me, for that way I could go over those questions. But yeah. All right. So for this one, if you look at it, it says probability of A is equal to 0.15. Probability of B is equal to 0.25. Probability of C is equal to 0.09. Probability of D, in my case scenario, I got 0.00. So it says assume events A, B, C, and D are disjoint events. So disjoint event just means they don't share anything. The same thing for mutually exclusive. So they're telling you they're nothing in common. So for the question, it says find the probability A or B or D. So if I want to find the probability of A or B or D, all I have to do is get the probability of A, add it to the probability of B, and lastly add it to the probability of getting D. Cool. So if you look at this one, all you have to do is just add these individual probability. So the probability of A is 0.15. Probability of B is 0.25. Probability of D, well, is 0.00, but I'm pretty sure probably some of you had a different value. So if I do 0.15 plus 0.25, you're gonna get 0.40. Any question how I got 0.40? Wait. So I give a 0.40, and then that's it. All right, on to question number 2. Oh. All right. Here we go, question number 2. So if you look at question number 2, it says probability of A is equal to 0.28, probability of B is 0.43, and probability of A and B is equal to 0.11. So if you look at the last probability, it's telling me it's possible for both of these events to occur at the same time. And if you look at my notes, oh, sorry, let me draw. If you look at the instruction I gave you right here, I even told you assume that event A and B are not disjoint. So that means they share something in common. So if you look at the question, it says find the probability of A or B. So if I want to find the probability of A or B, that means you have to get the probability of A, add it to the probability of B, and subtract it by the probability of A and B. All right. Any question in regards so far to that notation? All right, so if you look at the probability of A is 0.28. Probability of B is 0.43. And lastly, probability of A and B is 0.11. So let me go ahead and work that out. There you go, 0.28, oops, 28, plus 0.43 minus 0.11. So if you do that, you get 0.60. So if you look at it, it says give answer in decimal form and round answer to 2 decimal. But if you look at this one, there's no value right here. So you can just put 0.6 and that will give you the correct answer. So put 0.6. And let's go on to the next answer. Oh, next question. All right. But that was it for number 2. Any question for number 2? All right. So for this one, say a survey asking 500 Americans to list their top 2 television show gave the following result. 0.56 of Americans said Rick and Morty. So that's important. So probably somebody said Rick and Morty is equal to 0.56. 0.56 of Americans said Rick and Morty, and 0.38 of Americans said The Office. So say probably they chose The Office is equal to 0.38. And lastly, they said there were 0.31 of Americans that their top 2 show were both Rick and Morty and The Office. So that's probably a R and O is equal to 0.31. Any questions so far for the labeling? Oh, we have a question. Oh, no question. Wait, so it says, what is the probability that someone's favorite show is Rick and Morty or The Office? So if you remember for chapter 3, well, sorry, for chapter 5, I told you, you got to pay attention to these words or the key word. So right here, the key word is or. So this is telling us we want to do probability of Rick and Morty or The Office. So for this one, you have to kind of notice for these 2 events, they're not mutually exclusive. They share some information because they told us that some people chose both Rick and Morty and The Office for their top 2. So for this one, you have to say probability of Rick and Morty plus the probability of The Office minus the probability they watch Rick and Morty and The Office. So if I do 0.56 plus 0.38 minus 0.31, that should give you 0.63. So we'll put 0.63. 0.63. And that's it for question 3. Any question in regard to problem number 3? All right. Maybe the hell you erase it. All right. So if you look at this one, it's exactly the same thing. The only thing is the numbers are slightly different. So we have 0.55 are Rick and Morty, 0.36 are The Office, and they say 0.30 watch both of these shows. So if you look at this question, it says, what is the probability that someone's favorite TV show is not? So that's the key word, because not mean we're using the complement rule. And if you remember, the formula for the complement rule is this. So in order for me to find the complement of an event, all I have to do is do 1 minus that probability. So in this case scenario, we want to find the complement of people who watch Rick and Morty, because we want people who don't watch Rick and Morty. So we want to find the probability that is not Rick and Morty. So you do 1 minus 0.55, and that's equal to 0.45. So your final answer will be 0.45. And that'll be it for question number 4. Any question in regard to problem number 4? Oh, another no. All right. So if you look at this one, it says if two events are independent, would that represent that the two event will also be mutually exclusive? So that's saying if I already know the events are independent, does that automatically mean they're gonna be mutually exclusive? And what you could have done for this one is you could have gone in the example. So if you remember the example that I gave here for like independent event, dependent event, like here, let me just go to the lecture notes. So one of the example I gave, oops, let me withdraw. On the lecture notes is I say A row A6, and we'll say B toss. So if you remember, I gave you two examples. Well, I gave you multiple examples. So I gave you multiple examples, but one of the examples I gave you is if a person roll a 6 on a die and a person flip a coin and get tail, these two events are independent from each other because the probability of me rolling a 6 is going to be 1 out of 6, and the probability that a coin will land on tail is 1/2. So these two events are independent from each other. And then what you could go ahead and do, look at these two events and you could ask yourself, are these two events mutually exclusive? So if I roll a 6, does that make it impossible for me to toss or for me to flip a coin and get tail? Like, no. So for the answer for number 5, you just have to say no and then put whatever reason why is no. If you put an example, the example is kind of like the easiest way to show why it's not mutually exclusive. Because roll a 6 and toss a tail, like those two events are not mutually exclusive. Any question in regard to that? Yeah, I'll open up the quiz. Let me finish this. All right, and for the last problem, pretty much I just wanted to see if you know notation. So I say probability of A is equal to 0.66, probability of B is equal to 0.83, probability of C is equal to 0.94, and probability of D is equal to 0.56. So I just ask you, hey, find me probability that the complement of B, what's the probability of the complement of B? So if you look at the problem, I tell you, or I give you that the probability of B is equal to 0.83. So if the probability of B is that 0.83, if I want to find the complement of B, you do 1 minus 0.83, and you get 0.17. And that was the answer for the final question. Any question in regard to that last problem? Sweet. All right, so there you have it. That was your quiz. Any question in regard to the quiz? So yeah, so like I said, like for this quiz, or pretty much just for chapter five, you have to pay very close attention to the information that's given to you. Like some of you are also getting confused because I gave you like how big of a sample they have for the survey, but pretty much that was useless to you because pretty much I already gave you the probability because I already gave you the probability of 0.56, such and such. So you didn't really need to use the 500. So if you use the 500 for anything, it would have given you the wrong answer. What you wanted to do was the probability that we're giving you for the problem. All right, but that was it for today quiz. Any question in regard to the quiz before I move on to lecture notes? Wait. All right, let's go over lecture notes. All right, so if you do have questions, just try post them. Yeah, it was tricky if you weren't paying attention to the keyword, but I think like if you were reading the problem very well, should have been able to get those questions. Okay, so what we're gonna get into today, if you kind of remember, we went into the multiplication rule. I kind of show you how the multiplication rule would develop. So what we're gonna go ahead and do, we're gonna go ahead and illustrate that by using it on several problems today. So remember, for the multiplication rule, you want to use the multiplication rule when you're doing multiple selections. So if I'm selecting two objects, or if I'm selecting two people, you want to use the multiplication rule as long as your events are independent from each other. So let's go ahead and do this next problem. So for this one, it says, according to Sports Illustrated, 78% of NFL players who are retired for only 2 years file for bankruptcy. 60% of NBA players suffer the same fate. So we have NFL player after 2 years, they file for bankruptcy. And we also have NBA player that file for bankruptcy after 2 years after they retire. So let's do part A. So for part A, it says, is a NFL player independent from a NBA player? So kind of think about it like if I'm selecting an independent, an NFL player, will that affect me choosing an NBA player that's retired? So the answer for this one should be no. So we'll say this is independent. Cool. So for this one said, what is the probability that if we randomly select a NBA player and an NFL player who retire for 2 years, file for bankruptcy respectively? So let's go ahead and do this. So we'll say the probability that an NFL player file for bankruptcy is 0.78. And the probability an NBA player file for bankruptcy is 0.60. So for part B, how many people are we randomly selecting? Cool. So we're randomly selecting two people. One of them happened to be an NBA player, the other one happened to be an NFL player, but we're randomly selecting two people. So that's why for this one, what we want to do, we want to do the multiplication rule, because instead of randomly selecting one person, we're randomly selecting two people. So for this one, we're going to follow the order. So we want the first one to be an NBA player who filed for bankruptcy in 2 years. And we want the second one to be an NFL player who filed for bankruptcy in 2 years. So in order for me to do this, all I have to do is multiply these individual probability times each other. So we have to get the probability that an NBA player filed for bankruptcy in 2 years and multiply it by an NFL player who filed for bankruptcy in 2 years after they retire. Cool, we already got the answer going. Perfect. So we go 0.78 times 0.60, and we'll trust that answer to be 0.68. So remember the 0.68, that's 3 decimal places. So if I ask you to give me 3 decimal places, that should be the answer. If I were to say, give me 2 decimal places, all you have to do is give me 0.47. All right. Everybody good for B? All right, let's do C. So let's do C. So C says, what is the probability that if we randomly select 2 NFL players who are retired for only 2 years, file for bankruptcy? So for this one, how many people are we selecting? Cool, perfect. So we have 2 NFL players. So for this one, if you look at it, we want the first one to file for bankruptcy in 2 years after they retire. And we also want the second one to file for bankruptcy after 2 years that they retire. So we want both of them in 2 years to file for bankruptcy after they retire. So for this one, all we have to do is get the probability that the first one filed for bankruptcy and multiply it by the second one that they filed for bankruptcy. So for this one, we'll get 0.60. Oops, wrong. You get 0.78 and you multiply that by 0.78. So far, any question, I got 0.78 times 0.78. There you get 0.78. Cool, perfect. So you get 0.6084. And that's 4 decimal places. All right, and that's it for C. Any question in regard to C? All right, lastly, let's do D. So for D, so what is the probability that if we randomly select 2 NBA players who are retired for only 5 years, let's just say 2 years. So only 2 years file for bankruptcy. So for this one, we're changing it that we're randomly selecting 2 NBA players. So for this one, since we're doing 2 NBA players, we're gonna say probably the first NBA player filed for bankruptcy after retiring, and the second NBA player filed for bankruptcy after retiring. So for this one, what we have to do, we have to use the probability for NBA player, which is 60%. So you're gonna do 0.60 times 0.60. So if I do 0.60 times 0.60, you get 0.36. Cool. And that's your final answer. Okay. So if you kind of notice, like for these problems, it shouldn't take you that very long, just like what we did yesterday. It shouldn't take you that very long as long as you kind of know the key word. So right here, like some of the key word is you looking for how many people are they randomly selecting. Since they're randomly selecting more than one person, that's kind of telling you that we have to use the multiplication rule. Another thing, well, yeah, that's pretty much it. So you kind of have to just look at the keyword because the keyword will help you out to decide whether or not you should be applying that. All right. Any question for that first example? All right. All right, so let's go ahead and do this one. So it said the probability that a randomly selected person is left-handed is 11% according to the National Statistic Report. Cool. So this is the probability that a random person is left-handed. Cool. So if you look at this one, they gave me the probability. So I don't have to do anything else with this because they already gave me that probability. So for part A, it says, what is the probability that two randomly selected persons are left-handed? All right, so first thing, how many people are we selecting? Cool. So we're selecting two people. All right, so since we're selecting two people, that's kind of giving us that we should use the multiplication rule. Also, you kind of want to think about it. Say if I pick one person, does that make it more likely that the next person that I pick is going to be left-handed? No, so these two events are independent from each other. So since these two events are independent from each other, we're going to use the multiplication rule. So we're going to find the probability the first one is left-handed and the second one is left-handed. So we're going to get the probability the first one is left-handed and multiply that by the probability the second one is left-handed. So that's going to be 0.11 multiplied by 0.11. So 0.11 times 0.11. Cool. And you get 0.0121. So if you kind of look at this probability, it's kind of telling you it's not very likely that if I randomly select two people, that these two people will be left-handed just because there's not a lot of left-handed people. Because we only have 11% of the population that are left-handed. So if I'm going like randomly select two people and both of them are left-handed, it's pretty much telling us that's very unlikely to occur. But it's still possible because it's still higher than 0%. All right, everybody go with A. All right, so let's do B. So for B, I'm gonna show you how to do it two different ways, just notation-wise. So for B, it says, what is the probability that two randomly selected persons are right-handed? All right, so for this one, once again, we're randomly selecting two people. So what we want these people to be right-handed. So we can either write it like this, or we could write it so either way works for me. Okay, you could either say the probability that both of them are right-handed, which is right, or you could say the complement of left and the complement of left, which the complement of left is just you're right-handed. So first thing we have to do, we have to find the probability that somebody is right-handed. So if I know the probability somebody is left-handed, if I want to find the probability that somebody is right-handed, we're going to say 1 minus the probability somebody is left-handed, which is 0.11, which is 0.89. So 0.89, well, sorry, 89% of the population are right-handed. So that's how you want to do it, by taking the complement. So now if I want to find the probability that if we randomly select two people, that those two people will be right-handed, all I have to do is do 0.89, multiply that by 0.89, and let me just double check your answer just to make sure that you did it correctly. Cool, perfect. And you should get 0.7921. And that's your answer for B. Any question in regard to B? All right, so what I want you to do, I want you to practice on these next two problems. So once you get the right answer, once you get your answer, if you want to double check your answer to make sure it's correct, if you want to, you can either private message me your answer, or if you want, you can put it open into the chat. And that way I'll let you know if you did it correct or if you still need a little bit more improvement on it. So you try practicing on these two so that way you get that practice going. All right. Okay, so let's go over the problem. So for the most case, a lot of you got it right, but if you got it off, will you follow along with me? For that, we can kind of see what you did wrong. So for this one says, suppose 6% of baby born in the US have green eye. We randomly select 2 babies. All right, so we're randomly selecting 2 baby. So if I pick 1 baby, that doesn't make it. So say if I pick 1 baby and this 1 baby had green eye, the chances that the next baby have green eye is still gonna be the same chances because this baby doesn't influence the probability that the next one is gonna have green eye. So for this one, we're gonna say they're independent. And if you look at this one, how many babies are they choosing? Cool, perfect. There you go, 2 of them. All right. So since we're randomly selecting 2 baby and we know both baby are independent from each other, we're gonna do the multiplication rule. So if you look at the first one, it says find the probability that 2 randomly selected born. Let's start that again. Find the probability that 2 randomly selected baby born in the US will have green eye. So we want the first baby to have green eyes, and we want the second baby to have green eyes. So the probability that the first one had green eye, remember, you want to get that 6%, convert that into decimal. So, oh. So you get 0.06. So that's the probability that first baby had green eyes. But then we have the second baby and we want the second baby to also have green eyes. So we put 0.06. So if I do 0.06 times 0.06, you get 0.0036. Or if you want to put it as a percent, you put 0.36%. There you go. And that's your answer for part A. Everybody go for part A. So for the most case, most of you were able to get A. For some of you, the only hiccup you had would probably, instead of putting 0.0036, you gave me 0.36. So you kind of remember the decimal places. Don't forget about those 0. Like if the 0 come before the decimal, you could drop them. But if there's 0 between the decimal and the next significant value, you have to keep those zeros. All right, so let's do B. So for B, it says find the probability that a randomly selected baby born in the US will have green eye and the other baby will not have green eye. So pretty much we want the first baby to have green eyes. And if you look at this, it says not. Not, it's telling us we're finding the complement. So essentially we want a baby that has green eye and a baby that doesn't have green eye. So it doesn't matter for the second baby if it have blue eye, brown eye, black eye, hazel eye. All of those are good. All we want this baby to be is not have green eye. So first thing you want to go ahead and do is find the probability that a baby does not have green eyes. Because I know the probability that baby have green eyes is 6%. So if I want to find the complement of that, all you have to do is do 1 minus 0.06, which is 0.94. Good. So we want to find the probability that the first baby have green eye and then the second baby doesn't have green eye. So the probability that the first baby had green eye is 0.06. The probability that the second baby had doesn't have green eye, sorry, is 0.94. So if I do 0.06 times 0.94, you get 0.0564. And that's your final answer for B. So for B, that's how you wanted to do it. Because for this one, it's a little bit mixed, where the first baby had green eyes, but the second baby doesn't have green eyes. Any question in regard to B before we move on? All right, so let's move on down. All right. So for the next part, what we're gonna do, we're gonna expand on our formula. So if you remember our formula, let's go back to our regular formula. So our regular formula were for 2 random selection. So if I'm randomly selecting 2 people or 2 objects, you want to use this formula. But what the next formula is saying, it's not limited to just 2 random selection. For this one, we can have n many selections. So if I wanted to select 20 people, we could use this formula for 20 people. Or if we want to do it for 30 people, we could do this for 30 people. So what this next formula is saying, depending on how many independent events, if we want to find the probability of all of those events occurring, all we have to do is get those individual probability and just multiply them times each other. Because what this is saying, if all of these events are independent from each other, and we want to find the probability that event E1 and E2 and E3 all the way to En occur, all we have to do is just multiply all of those events probability times each other. So that's what we're going to go ahead and do on the next following problem. Any question in regard to to that formula or expansion of that formula? All right, so let's go ahead and do the next formula. So for this one said the probability that a randomly selected person is left-handed, well, it's still 11% according to the National Statistic Report. So for part A, it says, what is the probability that 3 randomly selected persons are left-handed? So for this one, how many people are we randomly selecting now? Cool. So we have 3 random selection. All right, so for this one, you have to kind of make it a little bit easier to write. I'm gonna say probability of L, where L stands for left-handed, is equal to 0.11. So instead of me writing left, I'm gonna put L. So for this one, what we want the first person to be left-handed. We want the second person to be left-handed. But lastly, we want the third person to be left-handed. So in order for us to find that, what we have to do is to get the probability the first one is left-handed, multiply it by the probability the second person is left-handed, and then multiply it by the probability the third one is left-handed. But for this one, since all events are independent from each other, you're going to say 0.11 times 0.11 times 0.11. Any questions so far? I got 0.11 times 0.11 times 0.11. Okay. And if you know some mathematical tricks, for this one, anytime you have numbers that are repeating, what you could do, you could always rewrite it as the base, which is 0.11, and then however many times it's repeating, you put it to the third power. So I'll show you how to do that with the TI-84. Probably some of you haven't used that function on the TI-84, so I'll show it to you real quickly. So if I want to do 0.11 to the third power, all you have to do is put 0.11. And then if you look over here, if you look right on the division button, if you look right above it, it has the arrow. It has the up arrow. So you press that, and then you press the number 3, press enter, and we're good to go. So we get the probability to be 0.0013. All right. So we're all done for that one. Any question for that part A? So let me switch back to the notes. All right. So for part B, it says, what is the probability that 3 randomly selected person are right-handed? So for this one, we're changing it where we don't want all 3 of them to be left-handed. Now we want all 3 of them to be right-handed. So we're gonna say probability, the first one is right-handed, and the second one is right-handed, and the third one is right-handed. So for this one, we'll say the probability, the first one is right-handed, multiplied by the probability the second one is right-handed, times the probability the third one is right-handed. So for this one, since I know both of the events are complementary of each other or mutually exclusive, can either follow that you're left-handed or you're right-handed, or that your dominant hand is left-handed or your dominant hand is right-handed. So for this one, if 11% are left-handed, that means 89% are right-handed. So we'll say 0.89 times 0.89 times 0.89. So let's do 0.89 all to the third power. And you get 0.70. Oh, what do you say, 5? All right, and that's it for B. Any question in regard to B? All right, so if you compare A to B, B is telling us it's more likely if we randomly select 3 people, it's more likely all of them are right-handed versus all of them being left-handed. Because if you look at the probability of it being left-handed, pretty much it's less than 1%. But if you look at the probability of it being right-handed, is pretty much 70%. So there's a pretty good chance that if we randomly select 3 people, all 3 of them are right-handed. So what I want you to do, I want you to try this next one. Once you get the answer, if you want, you can either put the answer on the regular chat board, or if you want to get private message me the answer, that worked well. All right, so try doing that. I'll be right back. There you go. There. All right, guys, so let's go over this one. So if you look at the first one, A, they're saying we're randomly selecting 3 people. So we're gonna say, well, 3 baby. So we want the first one to have green eye, the second one to have green eyes, and lastly, the third one to have green eyes. So we want all 3 of them to have green eyes. So you want to say 0.06 times 0.06 times 0.06. So let's enter that into our calculator. So in the calculator, you don't want to do 0.06 times 0.06 times 0.06. You should go like, okay, since 0.06, since that occurred 3 times, you want to do 0.06 to the third power. So we do 0.06 all to the third power. Cool. So we get this. So get 2.16 e to the negative 4. Everybody good on so far how we got that? All right, let's go over to my notes. Cool. All right, so the reason why the calculator gave you 2.16 e to the negative 4, were there are 2 occasions when it will do that. It will do that either if your value is extremely low or if your value is extremely high. In this case scenario, the value is extremely low. The reason why I know the value is extremely low, if you look at the e, it says e to the negative 4. So technically, this is in scientific notation, because in scientific notation, it'll be written as 2.16 times 10 to the negative 4 power. So that what the e to the negative 4 is, it's telling you this is in scientific notation. So technically the negative 4 telling you this is a really, really small number. So the calculator is telling you here this is, because essentially it doesn't want to give you all of this value. It would prefer to give it to you in scientific notation. So for your case scenario, you should know how to convert this from scientific notation into standard notation. And to convert this to standard notation is very simple, because this value over here, perfect. So the negative 4 tell you how many places to the left do you move the decimal place. The reason I know I'm moving it to the left is because it says negative 4. If it was a positive 4, you move it to the right. So you get 2.16. So you get this decimal place and you move it 1, 2, 3, 4, and you move over here. So then what you're going to notice you have some empty space. So anywhere you see these empty space, what you have to do, you have to fill them up with a 0. So for this one, we'll write it as 0, 0, 0. So our final answer should be 0.000216. Or if we just want 4 decimal places, it'll be 0.0002. So I do expect you to be able to get a scientific notation and convert it into a standard notation, because I guarantee you if you put 2.16, 2.16 is not going to be the correct answer. You want to know how to convert a scientific notation and how to convert it into a standard notation. All right, but that's it for A. So that's how you want to do A. Any question in regard to letter A? Cool, perfect. All right, other thing we're gonna do is letter B, or part B. So for part B, it's a little bit of mix and match, because essentially for this one, we don't want all the baby to have green eye, or we don't want all the baby to have not green eye. We essentially want to mix and match. We do want some of them to have green eyes. We want some of them to have something other than green eyes. So if you look at this one, we want the first one to have green eyes. And then we want the second one not to have green eyes. And then we want the third one to have green eyes. All right. So far, any question on so far the notation that I have in red? Wait. All right. So if you look at the probability that a baby have green eye is 0.06. So that's for the first baby. Now we're gonna move on to the second baby. So the second baby, we want it not to have green eye. So if I know 0.06 have green eyes, the probability a baby doesn't have green eyes is 0.94. Lastly, the probability the last baby had green eyes is 0.06. So if we multiply that all out together, you get a very, very small number of 0.003, and we'll round this up to 4. So that's your final answer for part B. Any question in regard to how I did part B? All right. All right. Some little advice, like if I were you, you shouldn't really write yet 0.06 times 0.94 times 0.06, because I guarantee you 90% of you, when you look back on your notes, you're gonna go, how did we get the 0.94? So if I were you, you should write, the reason I get 0.94 is because I do 1 minus 0.06, and that's how we get 0.94. So you do want to take some additional notes on little stuff like that, because something that seems so trivial or so easy at the moment, once you look back on the notes, like it's not going to be so trivial or easy for you. So you do want to put some little small help here to kind of help you out with how do you get the 0.94, where does the 0.06 come from, and so on and so forth. All right, but that's it for that last problem. Any question for that last problem? All right, let's move it on up. All right. So up next, we're gonna get into something called at least. So for this one, we're not gonna change the multiplication rule. We're actually gonna keep on using the multiplication rule, but we're gonna add the word at least to it. So a lot of students have a hard time with the word at least. So anytime we look at least is telling you this is the minimum, but it could be higher than this. So anytime you see the word at least means this is the minimum, but it could be higher than that. So if I tell you, in order for you to get at least a C in the quiz, you have to get at least, how much is it? Don't want to give you no false information. Like in order for you to get at least a C in the quiz, you need at least 18 points. Cool. So when I say at least 18 points, that means that's the minimum you could get to get at least a C. But if you want to get anything higher than that, you could get a 19 or 20 or 21, 22, 23, 24, 25. And all of those was pretty much, what do you call it, meet the condition. So anytime we say at least means that's the minimum, but it could be higher than that value. Any question for the word at least so far before we do an example for it? All right, no question. Perfect. All right, so let's do example 1. So it says the event is that a person wrote at least a 2. So the person wrote at least a 2. So what we want to do, we just want to write it out. So sorry about that. So the event will be, so say E will be 2, 3, 4, 5, 6. So for this one, if I say a person wrote at least a 2, that means the person, if you just want to write it as the event, got a 2, 3, 4, 5, or 6. Or you could write it out of the sentence and say they wrote a 2 or higher. All right, but that's it for A. Any question for A? All right, so let's do B. So for this one, we want to find what is the probability. So we want to find what is the probability of getting at least a 2. So we want to find that X is greater than or equal to 2. All right. So how many total number or how many total outcome do we have that give me at least a 2? Oh, 5. Out of how many total? How many total outcome do we have when we roll a die? 6. Perfect. So if I do 5 divided by 6, you get 0.8. So we get 0.83. So that's the probability somebody roll at least a 2. Everybody good with that first one? Yeah. Go on to this one. All right. So for this one, it said the probability model to the bottom showed the distribution of the number of movies a random person will see during the year. So this will be before COVID. So all of these numbers should be way higher now. So it said either a person could watch 0 movie throughout the whole year, 1 movie, 2 movie, 3, 4, 5, 6, 7, or 8 or more movie. So for part A, it says, what is the probability a person see at least 1 movie this year? So if you want the person to see at least 1 movie this year, how many, like, is there just 1 row that I should get, or is there multiple rows that I have to get in order to get this? Like, which row would count? So, okay, so we got row 1. Cool. Is that the only row that worked out? Because it says at least 1 movie. Cool. And everything below. Cool. 1 through 8, except for 0. Perfect. All right. Everybody get why we selected those? All right. So if you look at this, let's kind of go back. So if you remember, back when we did the probability rules, we said there were 2 rules for the probability rule. One of the rules said that all the probabilities should be between 0 and 1. And the next rule says if I add up all the probability, it should add up to 1, correct? So these are 2 rules that we learned probably like in the beginning of chapter 5 or the very beginning of chapter 5. So we're still going to use these rules. But if you look right here, the problem is not telling me to check for this condition. So if the problem is not telling me to check for this condition, we could already assume both of these conditions had already been met. So I could just go ahead, if I want to find the probability of somebody watching at least 1 movie, I could go ahead and do 0.032 plus 0.093 plus 0.176 plus 0.219 plus 0.189 plus 0.122 plus 0.079 plus 0.08, and that will give me the correct answer. But what would be an easier way to do this? Perfect. So you want to use the complementary rule. So you want to say 1 minus the probability that x is equal to 0. So this is a very important formula. You could use this formula, and this formula actually does come up a lot. So anytime you want to find the probability of x is at least 1, all you have to do 1 minus the probability that x is equal to 0. So this will be 1 minus 0.01. And remember, the 1 is coming from this one over here. So you get 0.99. And that's it in regard to part A. So you do kind of want to know the complementary rule, because the complementary rule will help you out so much for this. Because instead of you adding up all of those, how many, 8 numbers, all you have to do is get the probability of 0, and you do 1 minus that probability, and you're all done. All right. Any question in regard to A before we move on to B? All right, let's move on to B. All right, so for the next one, it says, what is the probability a random person see at least 5 movies this year? Okay, so if I want a person who watched at least 5 movies this year, where should I start off at? Which row should I start off at? Cool. So we start off at 5. But is that the only row I want? So you want 6, 7, and 8. All right, so if you look at this one, I could go ahead and try to see if I could use the complementary rule. But if you look at it, if I want to do the complementary rule, it's actually going to be more harmful than good. So in this case, we're not going to do the complementary rule, because if I find a complementary rule, I have to find the probability of 0 through 4 and then do 1 minus that. And that doesn't really make sense, because in that case scenario, I have to add more number and still have to do 1 minus it. So for this case, we're not going to do the complementary rule. We're going to do it the old-fashioned way, and you just add these up. So we're going to do 0.189 plus 0.122 plus 0.079 plus 0.08. So I'm going to go ahead and add that up to my calculator. So if I add that up in my calculator, I get 0.47. Cool. Everybody go for B. All right. Before we move on to C, for this problem, how do I know I'm not doing the multiplication rule? Like, what's a good hint that's telling me for this problem, we're not going to have to multiply any probability? No. Well, when did I tell you you do the multiplication rule? What had to happen in order for you to do the multiplication rule? Well, what do you mean by 2 of the same? But before that, before we even know about that they're independent, what has to happen? Now the value have to be equal. Cool. Well, what about random selection? How many random selections should we have? 2 or more. Perfect. So if you look at this one, how many random selection or how many random person are they selecting? Well, if you look at it, it says a random person. When they say a random person, that means they're only selecting one person. So you do want to start picking up on this, because like I'm saying, like chapter 5 is probably the most difficult chapter. So if you could start picking this up right now, it's gonna make chapter 6 and chapter 6 a lot easier. So for this one, if you look at it, it says, what is probably a random person, which just means one person. All right, let's do C. So part C says, what is probably a random person see at most 3 movies this year? So right here, the keyword is at most. So when you see at most, that means it's the max, but it can be smaller. So whenever you see at most is saying that's the max it could be, but it's okay if it's below that max. So for this one, what's our max? So for this one, our max is, it said at most 3 movie. Our max is 3. Oops, don't want to erase. All right. Took long. All right. Cool. All right. So 3 is our max, but which other row should I select? Remember, we said that's our max, but it could actually be lower than that. Cool. 0 to 3. Perfect. All right. Any question while I'm selecting row 0, 1, 2, and 3? All right. So what I'm going to go ahead and do is just add those probabilities. So we're going to say at most 3. So you get 0.01 plus 0.032 plus 0.093 plus 0.176. Right. So I'm going to add those 4 up. Once I add those 4 up, we're all done. 0.01 plus 0.032 plus 0.093 plus 0.176. So you get 0.311. Okay. So there's a 31% chance that a random person will watch 3 movies for the year. I think I do that for the week now. All right. But that's it for the last problem. Any question in regard to this last problem? All right. So these are kind of the softballs. These are kind of getting you used to the word at least. So what we're going to go ahead and do, we're going to go ahead and now use the word at least, but now we're going to mix it in with multiplication rule. So hopefully you're prepared. So let's go ahead and read this prompt. Cool, good job. So for this one said the probability that a randomly selected student from West Los Angeles College transfer out rate is 17% according to the usnews.com/education. So that means 17% of West Los Angeles College students transfer out. So for part A, so let's do this. So we'll say T. So that's the probability that somebody would transfer out. So the probability somebody transfer out is 0.17. So for part A, it says, what is the probability that a randomly selected student from West Los Angeles College does not transfer out? So right here, you want to pick up on 2 things. What's one of the things that you should pick up on? Perfect. The not. Because this is essentially telling me we're using the complementary rule. Cool, perfect. You even put it in the thing. All right, cool. Thank you, Lisa. So the other thing you want to notice is a randomly selected student. So that means there's one selection. So those are the two things that you want to pick up that they said not. So that means we're using the complementary rule. The second thing is that they say a randomly selected student. So that means we're only selecting one student. So what we're gonna do, we're gonna find, how is that? We're gonna find the probability somebody does not transfer out, which is equal to 1 minus 0.17, which is equal to 0.83. Cool. And we're all done for A. Any question in regard to A? So just remember, like chapter 5, the math is the most simplest thing to do, but it's pretty much just deciding which formula to do it that make it the hardest. So you kind of want to start getting these formulas down for that way you can start noticing like when to use a formula, when not to use a formula, stuff like that. All right, let's do B. So for part B, it said, what is the probability that at least one of 5 randomly selected students from West Los Angeles College transfer out? All right then. So what do you notice the difference about part B? Like one is one of the glaring difference. Cool. So we have the famous at least. What else do we have? 5 students. Oh, perfect. So we have at least, which we already know at least means that's the minimum, but it could be anything higher than that. And we have that we're randomly selecting 5 students. All right. So before we kind of go ahead and do this problem, what I want to make a table because I'm hoping this table should make it easier for you. But like on tests and quizzes, you don't have to do this. You can go straight to the formula to do it. But hopefully hopefully this will help you out. Okay. Cool. All right. Let me kind of blow that up for you in case you can't see it. So it says how many students transfer out? And then what I did, I said that is equal to event A. So on the right side, we're going to find the probability of event A. All right. So let's go ahead and do that. So for how many students transfer out? So if I have 5 students, what's the lowest amount of students that could transfer out? There you go. So technically the lowest amount of students that could transfer out is 0. So we could have 5 students and none of them transfer out. What's the next lowest? So 1. What's the next lowest? Go. Which is the next one? Go. 3, 4, 5. Cool. All right. So that's it. So this is our distribution table, or probability distribution table. So it could be that 0 people transfer out, 1 person transfer out, 2 people transfer out, 3 people transfer out, 4 people transfer out, or all 5 of them transfer out. All right, but let's look at the question. So for this one, it said, what is the probability that at least 1 of 5 randomly selected students from West Los Angeles College transfer out? So I want at least one of the 5 to transfer out. So of all of these numbers that I have from 0 to 5, how many of them should I use? Like, which one should I use? Or which one do I have to find the probability? 1 through 5. So I have to find the probability of 1. I have to find the probability of 2, 3, 4, and 5. So if you look at it, I have 5 unknown. So that means if I wanted to find the probability of at least 5 students randomly selected, I'm gonna have to find 5 separate probability. All right, so that seems a lot. But if you look at it, which one of the probability that I don't want? So I don't want 0. So if I want to find the probability that X is at least 1, we already said to find the probability that X is at least 1, all we have to do is get 1 and subtract it by the probability that X is equal to 0, which is this fellow over here. So that's what we're going to try to go ahead and do. We're going to find the probability that X is equal to 0. So let's go ahead and find X is equal to 0. Any question on this formula? All right, so if X is equal to 0, if X is equal to 0, what does that represent about well, not people, but students transferring out from West Los Angeles? Does that mean that all of them transfer out, or does that mean that none of them transfer out? So none of how many? So is it none out of 1, none out of 2, none out of 3, none out of 4? Is none out of how many? Is none out of 5. So for this one, we have, oops, sorry about that. So for this one, we have 5 students. And what we want all 5 of these students to not transfer out. So we want the first student I randomly select not to transfer out. I want the second student that I select not to transfer out. I want the third student that I select not to transfer out, all the way to the last student to not transfer out. So what is the probability that this first student doesn't transfer out? 0.83. Perfect. What's the probability that the second student that I randomly choose from West Los Angeles College does not transfer out? Cool. So we can just assume this is all the same. Because since we want none of them to transfer out, that way we're doing 0.83 times 0.83 times 0.83 times 0.83 times 0.83 because we want all 5 of them not to transfer out. Because remember, we want to find the probability that X is equal to 0, which means none of them transfer out. Any questions so far on that? All right, so obviously for this, I don't want to manually have to put this into the calculator. So we're going to do 0.83 to the 5th power. So let me transfer over to my TI-84, and we'll do that. So we'll do 0.83 all to the 5th power. Cool. And if you look at that, we get that. So we get 0.39, we'll say 39. All right, everybody got, I got 0.3939. All right, so let's go ahead and go flash back to my notes. So if you notice, I now have this filled out. So if you look at it, we have the probability that x is equal to 0. I still don't know the individual one. I still don't know what this is, what this is, what this is, what this is, or what this is. But do I really care if I don't know that? Not really, because I want to find what the probability of all of those values added up together. So since I want to find the probability of all of those values added up together, we're going to do the complement rule. So now we're going to do 1 minus the probability that x is equal to 0, and you get 0.3939, which if I do that, you get 1 minus 0.3939, and you get 0.6061. Good. And we're all done with part, which part is this, B? B. So pretty much for this one, this is a combination where we get the at least statement, and then we introduce it to the multiplication rule. So you do kind of want to know each one of them, because pretty much for the at least statement, as soon as it says at least one, you should automatically know that you want to do 1 minus the probability that x is equal to 0, because that's pretty much the easiest way to get that probability. All right, but everybody, or does anybody have any question in regard to part B? All right, so let's do part C. So for part C, it's the same thing. What's the only thing that's changing in part C? Cool. 10 randomly selected students. So we're not randomly selecting 5 people, we're randomly selecting 10 people. So for this one, it's still the same thing. We still want to find the probability that at least one of the 10 student transfer out, but we're switching it up. Instead of saying we only have 5 students that we're randomly selecting, we're gonna have 10 students that we're randomly selecting. So we're gonna say probability that x is greater than or equal to 1, which is equal to 1 minus the probability that x is equal to 0, which is going to equal to 1 minus 0.83. And what's the only thing I had to change to the 0.83? What should I do to it? Perfect. You take it to the 10 power because that's how many students you're randomly selecting. All right, so let's go ahead and just figure this out. So let me transfer back to my calculator so that way you can see how I punch it in. So we can say 1 minus 0.83 all to the 10 power. You press enter and you get 0.8448. So if you look at it, it's telling us the probability that at least one of 10 students transferring out from West Los Angeles College is 84%. So that's pretty good because it's telling me that at least one of the 10 will transfer out. So that could be 2 of the 10 transfer out, or it could be 3 out of the 10 transfer out, or 4 of the 10, or 5 of the 10, or 10 of the 10. So that's what the at least is telling you. It's telling you that's the minimum they could transfer out, but it could be possible that more of them actually do end up transferring out. And that's it for part C. So let me switch it over back to the notes for that way you can see how I wrote the answer. All right. So if you look at it, I just wrote like this. All right. So let's move on down. All right. So we're gonna go on to 5.4. So 5.4 5.4 is kind of a little bit of the same of what we did, if you remember, at the end of chapter 4. If you remember, chapter 4.4 was the two-way table and the conditional probability. We're kind of going to retouch that topic right here. So for this one, we're going to go over conditional probability, but we're also going to go over the general multiplication rule, but this is going to be for dependent data set. So 5.3 kind of focused on the multiplication rule for independent data set. 5.4, we're going to focus on the general multiplication rule for dependent data set. All right, so let's get started. So if you kind of remember the conditional probability means that there's a condition. So instead of using the whole table or all your sample, the conditional probability telling you that you're only going to pick the people or the object that meet that condition. So if you look right here, here's the Venn diagram. So if you kind of remember, a Venn diagram only has A and it has your B event. But for this one, the condition is that it's an A event. So instead of using A and B, we're only using the condition of A because we only want to focus on people or object that meet condition A. So anytime we're doing conditional probability or anytime it says given that means we have a condition and we're only going to use the object or the people that meet that certain condition. Right. So that's conditional. Everybody good with conditional? All right. And just remember, for both of these, this is for when we're doing a random selection. So we're only randomly selecting one person. We're not randomly selecting like 2 people or 3 people or 4 people. This is only for one random selection. So if you look at the AND statement, you still have your A and your B. Because remember, for the AND statement, you use the entire data set. So if you have an AND statement, you use the entire data set. So that means you divide by the total. And because you're not giving any condition, you're just dividing by the total amount of data set. All right, so that's the AND statement. Any question for AND? All right, so for this one, we're actually going to give you a formula for the conditional probability. So the rate, not the array. The way that we read this is right over here. So it says in general, probability of A, vertical line B. So it means that the probability that event A occur, given that the event B has occurred. So for this one, B is your condition. So whatever you have after the vertical line, that's telling you this has already happened. So anytime you have something after the vertical line, that means that this has already occurred. So if I tell you what's the probability you bring an umbrella, given that we already know it's rainy. So in this case, you put umbrella in the beginning and you put rain in the back end because I already know it's rainy and I want to know what are the chances that you bring an umbrella given that you already know it's raining. All right. Any question in regard to that? So A can happen without B. Correct. Because you could, like for this problem, you could still bring your umbrella even though it's not raining. Because you could bring the umbrella thinking it's going to rain, Or you could bring the umbrella given it's not raining, thinking it might rain later on. So yeah, so A could still occur given that B doesn't happen. All right, so here is the formula. So for this formula, I kind of want to go back to this. The probability of A given B. Oh, well, in this case, B given A. All right. So this is our formula for conditional probability. So if you notice right here, the condition is that event A has already occurred. So that's why only A is selected. Or let's see, only A is selected. So if you look on the top it says the probability of A and B, which is this portion over here. And you divide it by the probability of A, which is this entire portion over here. So that's how the probability, or that's how the formula works. You get the probability of A and B that they share, and you divide it by probability of A because that's the information you already know has happened. So instead of using the entire data set, you're only using the data set that we already know has happened. And just remember, whatever the condition is, that's always going to the bottom. So if it's a probability of A given B, it'll be the probability of A and B, but now the bottom will be the probability of B because B is given. Right. Any question in regard to the formula? All right, no question. Let's go on. All right, so let's do this fun problem. So for this one, what we want to do, we want to see if your education level affect the way that you think about true love. So let's read the problem. It says people in a study were asked whether they agree or disagree with the statement that there is only one true love for each person. Is the level of a person's education related to the answer given? And if so, how? A person's education is categorized as high school degree or less, some, which means some college, or college, which is college graduate or higher. So right here it has the high school, some, and college. Right here it has agree, disagree, or don't know. So let's go ahead and do this problem. So one thing that you kind of want to do first, you kind of want to go ahead and do the totals. So what I'm going to go ahead and do, I'm going to go ahead, right now I'm going to do all of the rows. So I want to see how many people agree with the statement. So that means I'm going to add up all of the number I just highlighted. So we're going to say 363 plus 176 plus 196. There you go, 735. Let's do the next row. So the next row is for people who disagree with the statement. So we'll go 557 plus 466 plus 789. And we get 1,812. Lastly, we have people who don't know. So we got 20 plus 26 plus 32, and you get 78. All right. So I'm all done with the rows. So let's do the columns. So I want to get how many total people do we have that have a high school degree or less. So we're going to say 363 plus 557 plus 20. So we get 940. So now I want to do people who have some college level. So I'm going to add those three numbers. So 176 plus 466 plus 26. So you get 668. All right. Lastly, I'm going to do people who have college level education. So 196 plus 789 plus 32. And you get 1017. So last thing I'm gonna get the total. So I can either add up all of these numbers, or if I want, I could add up these three numbers, and it will give me the total amount. They get 940 plus 668 plus. Right, so you get 2625. All right, so for part A, where it says how many total people were surveyed, well, the total amount of people that were surveyed was 2,625. All right, everybody go for A. All right, so let's do B. All right, so remember for this section, you gotta look for the key words for these problems, because if you can't find the key word, it's gonna really make it hard for you for this chapter. I'm telling you, this chapter is probably the hardest of all the chapters, like just reading wise. So you do want to pick up on little hints. So for this one, says find the probability a person agree with the statement given. It's already known that their education level is high school degree or less. Well, yes, the reading why. Well, probably chapter 10 will also kind of make this one look a little bit easier. But all right, so for this one, what's already given? What information do I already know? Do I already know they agree with the statement, or do I know their education level? So I know both of them. So I know their education. For this one, what the key word? Well, what do you think is the key word? So right here, the key word is given. Because if you remember, in the very beginning, I put given, and we said this is a conditional probability. So right here, the key word is given that, or given. So given is telling us this information, I'm giving you this information. So they're literally giving you this information that this has already happened. And we want to find what the probability that this other event occurred. So for this one, we're going to write a probability you agree with the statement given they have a high school education or high school or less education. Yeah, so we know their education level, but we don't know that they agree with the statement. Any question in regard to this so far? All right, so let's go ahead and do this problem. So for this one, if I'm using the formula with a probability that they agree with the statement and they have a high school education or less. For this one, what should I divide it by? Should I divide it by the fact that they agree with the statement, or should I divide it by they have a high school degree or less? Oh, high school, perfect. All right. Everybody good so far on how do I have this set up? All right. So you want to go back to the and statement. So if you remember for the and statement mean we want that one person to meet both criteria. So we only want to focus on people who have who agree with the statement and have a high school degree or less. So I'm gonna go back to the chart. And the easy way to do this is to do this. So first select agree with the statement. These are all the people who agree with the statement. Then go, how many of them have a high school degree or less? All of these people. So what you want to go ahead and do, you want to see where do they intercept? Because where they intercept are the people that meet both conditions. So how many people do we have that agree with the statement and have a high school degree or less? Oh, 363. So you put 363 and you divide it by the total. All right. Everybody go with that first fraction. All right, so let's get the second fraction. So if you look at the second fraction in the bottom, it says find the probability they have a high school degree or less. So if you look at this one, it doesn't have an and statement, it doesn't have anything to it. We just want to find out what the percentage of people that have a high school degree or less. So for this one, how many people do we have that have a high school degree or less? 940, perfect. Wait. All right, everybody get where the 940 coming from? And if you're not, there it is. All right. So once again, for this one, you divide it by the total amount. All right. So far we have 363 divided by 2,625. We have 940 divided by 2,625. Any question in regard to that? All right. So if you took in an algebra class or anything like that, this is called a complex fraction because you have a fraction on top of a fraction. So in order to get rid of the fraction that's in the bottom, what you have to do, you have to multiply by the reciprocal. So the reciprocal, pretty much that fraction, you flipped over. So if I look at this fraction over here, this fraction flipped over, will it be 2,625 divided by 940. But whatever you do to the bottom, you do it to the top. So you do 2,625 divided by 940. All right. So this and this cancel, this and this cancel, this and this cancel. So I'm left with 363 divided by 940. All right. Everybody get how we got 363 divided by 940? Okay, so if you go ahead and work out 363 divided by 940, you should get 0.3862. And that's your final answer for this one. Everybody good with that final answer? All right, everybody's good. All right. If you remember chapter 4.4, hopefully you remember it just a little bit. For 4.4, we actually went over this and we actually did it an easier way. So you could also do it the easier way. This is just if you want a formula for that way, the formula could kind of help you out. But if you're okay doing the way that we did in 4.4, just go ahead and do it the way we did in 4.4. Because if you look at this one, for this one, what's my condition? Is the condition that they agree with the statement or that they're a high school degree or less? Yeah. So that's a condition. So, oops, I don't want to erase that. So what I want to do, I just want to focus on that one column. I don't want to focus on people who have some college or above. I only want to focus on people who have a high school degree or less. So in this case scenario, you have 940 people that have a high school degree or less. Of those 940 people that are highlighted in yellow, how many of them agree with the statement? Oh. And that's how you get that fraction. So when you're using a two-way table, it's not very advantageous for you to use a formula. Like if I were you, yes, pretty much use the two-way table in your favor in order to do this. Because a two-way table is actually very simple to get these conditional probability. Because for part C and part D, I'm actually just gonna use the table instead of having to use this formula. All right, so let's go on to the next one. Let's do part C. So for part C, it says find the probability that a person agreed with the statement given it's already known that their education level is some college. So for this one, what do we already know? That they agree with the statement, or did they have an education level that has some college? Yeah. So we find the probability they agree, given they have some college. Everybody good so far with the notation? All right. So if you look at this one, the condition is that they have some college. So I'm going to go over here and we're only going to focus on people who have some college. So how many total people do I have that have some college level? Yeah, 668. Is it 668? Of those 668 people, how many of them agree with the statement? 176, perfect. So if I do 176 divided by 668, you get 0.2635. And we're done for C. So if you look at C, we were able to do it way much faster than we did B because you're just using the table and you're just using the fact that you know what the conditional probability is. The conditional is telling you you're not using the entire table. You're only using the portion of the table that you want. All right, so let's do D. So for D, it says find the probability that a person agree with the statement given it's already known that their education level is college graduate or higher. So for this one, we'll say probably agree, given college. So I'm gonna go ahead back over here. Let's do this. So now we're only focusing on college degree or higher, or college graduate or higher, sorry. So for this one, well, we already got the answer up, so I'll just use the answer. So let's say 196 divided by 1,017. Yeah, it is way better. All right. So let's do E and then we'll do F and then that's it for today. So for E, it says what the probability that a person agree with the statement and their education level is high school degree or less. So for part E, what's the key word? Perfect. Think you're getting it now. So it's and. But if you look at this one, how many people are we randomly selecting? We're only doing one because remember, we do the and statement and we do the multiplication rule if we're doing more than one person. But for this one, since it's one person we're randomly selecting and it's and, that means that one person had to meet both criteria. So for this one, we want to find the probability they agree with the statement and have a high school degree or less. So let's go ahead and find that. So we want people who agree with the statement and have a high school degree. So how many, how many people do we have that agree with the statement and have a high school diploma or less? 363. And for the 363, what do we divide it by? Do I divide it by the total or do I divide it by like one of these over here? You divide it by the total for this one. And remember, for this one, you divide it by the total because they don't give you a condition because they just want the probability. So in this one, we don't know if they have if they agree with the statement or if they have a high school education or less. We just know we want one person to meet both of these criteria. So since we don't know anything about these people, you do it from the total. So you do 363 divided by the total, which is 2625, and you get 0.1383. And that's it for E. Any question for E? All right. So up next for F is saying comment on part B, C, and D. So this is B, this is C, this is D. So what does it look like is happening? Are all three education level agreeing the same amount? Or what tend to happen? Like the more education level it seems they're getting, do they still believe that there's one true person out there for everybody? Cool. So yeah, so one person put in the less education, the more they agree with the statement. The more education, the more they disagree. Cool. Yeah, and that's it for that one. So you kind of showing you like the more education level they have or the more exposure they have, like the less and less they believe that there's one true person out there for everyone. All right. And that's it for that. We'll end on that note. Any question in regard to this problem that we did? All right, sweet. All right, so just remember for chapter 5, keep on writing notes, like keep on writing keywords because I'm telling you, chapter 5, you have to just kind of know like, okay, are they randomly selecting one person? Are they randomly selecting 2, 3, 4 people? And you do have to look at the keyword like given or and or, because all of those will occur. And you kind of want to know based off of that, like what type of formula you should use. All right. Any question before I end this meeting? All right, cool. All right, so have a good 4th of July weekend. Come back safe on Monday, and we'll pretty much continue this on up. So for the test number 2, test number 2 is not going to be this Monday, but it's going to be next Monday. So let me look up the date for that. Because if you already look at it, so on July 13th, you should have your second exam. So you do kind of want to start prepping ahead because there's only one more chapter left after chapter 5, which is chapter 6. So do start preparing your notes so that way you could do good in test number 2. All right, so that's it for today. I'll upload the video and the notes on Canvas in case you came in late or left early.